Okay, here we go.
Okay.
Hold on a second.
So Bart has decided that's enough about that. Where's my fork?
I don't know, did Jesse bring one?
Jim in. I'm gonna eat this with my hand.
So we're going to talk about something that I've been noodling on for quite a while, and we'll see where it goes. We're going to talk about something that comes up in quantum mechanics called entanglement, where things get tangled, obviously. And then we're going to talk about what they might have to do with consciousness and free will. So it looks very bizarre, like how could these things have anything to do with one another? And we'll see if I succeed in convincing you that they're actually related to one another.
That a murmuration of birds?
This is entanglement is up here. So you have two different entities, but they're coupled together, even though they're apart. If one of them gets, I'll just say, measured, you actually look at it, the other one will immediately get locked into whatever the other state is. So that's a picture there. This is a picture of consciousness here. This is a picture of free will up here with people going crazy. And this is a different sort of notion of group free will, of this swarm of locusts going crazy.
Thank you. I need something to drink, Jesse.
So anyway, we'll see. What I'm looking for is, where did our picture go? You got Bruce. No?
Huh?
Do the view where they're stacked.
Here it is.
Man, I need some water.
Now we lost Bruce completely. Where did Bruce go? You still there?
Yeah.
Hold on. I don't see the, let's see. Let me just get out of this. Hold on a second. Let me see. Something happened, obviously. This. Okay, now this looks good. Okay.
Okay.
Thank you, Jesse.
So first we're going to start with entanglement. So this doesn't arise in classical physics. This is totally something unique to quantum mechanics. So there's an example that was developed by Schrödinger, and he said, suppose you have a sealed
Box.
glass jar,
Okay.
and inside the glass jar there's a cat, and the stopper on the glass jar is connected to a it's connected on a chain to some to a vial, and if you pull on the chain, the vial will open up and there'll be this incredible poison gas, and the cat will be dead. So here's the question. You have the cat there, you have this poison gas, but the cat's alive. The cat you haven't pulled on the chain to get the poison gas going. On the other hand, if you do pull on the chain, then the poison gas will be there and the cat will be dead. So the cat will be in one of two states, alive or dead. And when the cat's alive, the gas won't have gotten out. And when the cat's dead, the gas will have gotten out. So the two different things are entangled together to one another. And it's all triggered by you trying to go observe what's really going on with the cat. So if you did something stupid and just accidentally pulled on the chain, and as you opened up the stopper, then you'd find a dead cat. But if you're careful and pulled on the stopper and the chain didn't trigger the gas, then the cat's alive. So it's your chance to observe one of two things happening. And the example here that's shown is you have photons a laser goes through a crystal, and then the crystal ends up polarizing the photons. So some are polarized so they oscillate vertically, and others are polarized so they oscillate horizontally. And there can be a mix of the two. The problem is, for any given photon, it could be either horizontal or vertical. Which one is it? It's only when you go to measure what's going on that you destroy this. And so this is really at the heart of everything. Another example is in the hydrogen atom, where you have one electron running around the nucleus, which consists of one proton. Now, the one electron actually could be in one of two states. It could be spinning clockwise, or it could be spinning counterclockwise. And people discovered this the hard way when they discovered that some hydrogen atoms had things where the electrons were spinning, say, clockwise, and others were spinning counterclockwise. And the coupling between these two different states, one clockwise and one counterclockwise, led to hydrogen having a very distinctive resonance. The wavelength is 21 centimeters, and the speed of light is 3 times 10 to the 10th centimeters per second. So if it's 21 centimeters, it's 1.4 gigahertz is the frequency, which is right in the middle of the cellular band. So hydrogen, the hydrogen resonance between these different hydrogen atoms with the spins there is all over the universe, because hydrogen is far and away the most common element in the universe. So because once you look at, for example, is the cat dead or alive, you find out it's dead or it's alive. Once you do that, then that fixes everything. So the other examples that people have done is they, for example, have these two electrons, and you could think of them as actually sitting in the same little container, one spinning clockwise and one spinning counterclockwise. So the container can hold one of each type. It can't hold two of the same type. That doesn't work. So if I took the space compartment that it's in and I just stretched it, and Ron Cowan saw this, he saw things that were space can be stretched. Sounds crazy, but it can be. So he saw things that were stretched millions or hundreds of millions of kilometers, okay? And there was light running through these things. And clearly the astronomers have seen this, and somehow this is being suppressed is the only thing I can think of, because you can't possibly miss a straight line that goes for, hundreds of millions of kilometers. But the net of it is that if it's just holding two electrons, say one here and one there, and there's a distance in between them, if I take one of the electrons and flip it so that it now is spinning the other way, the one out here can't be it's in the same space compartment. It'll flip too. It has to. So no matter how far apart they are, if I flip one, the other one will flip instantaneously. Not at the speed of light, instantaneously. That's what is spooky about this, is this operates over any distance you could think of. So it's one of these things that has come up, and it's been, initially people made fun of this. They said this couldn't possibly happen, but in fact, what they've done is, let me go back here and see if here's an example of two photons I gave you, with one being polarized horizontally and one vertically. The other example is two electrons, one spinning up or spinning clockwise and the other is spinning down. So all of this starts with the fact that the total system state here is going to have to involve, say, both electrons or both photons, or the cat and the vial of poison. The system consists of all these things, and the state that they're in correlates them. So if the cat is alive, then the vial of poison is closed. If the cat is dead, the vial of poison is open. Those are the only states you can have. And the thing that happens here is you think, well, I have a cat and I have some poison, what's the problem? But the fact is that those are the only possibilities. You can't have the cat dead and the poison not open. You can't have the cat.
You could.
Or the cat alive and the poison is spilled.
Maybe not.
The cat is what it is.
The cat could just die, though.
Yeah, no, the cat could. So this is an example of local behavior in a system that leads to complexity. Here we went from just say one electron or one photon. We only get this behavior when we have at least two things. And so the more things you get in the system, the more complexity you get, then the more likely it is that things like this are going on. And that is what people have been observing. The thing in classical physics is you can measure the position of something, or its velocity, or its spin, or its polarization. That's all fine. But in quantum, in the quantum world, where these things are coupled to one another, there's this incredible correlation that occurs. So for example, if I said that the total spin is known to be 0, and one particle has a clockwise spin and the other particle has a counterclockwise spin, then the spin is, when I add the spins up, they're 0. But if it's always 0, the spins could flip on me, and it will still be 0. But once one flips, the other flips immediately. So this has been demonstrated for photons, for electrons, in molecules even, and even in small diamonds, okay? And so because of this possibility of being able to have this thing happen instantaneously, people have said, I wonder if I could make a communication system out of this that would be faster than the speed of light. So far, no one's figured out how to do it, but they're racking their brains on what will work. In 1946, John Wheeler, who had just supervised Richard Feynman. Richard Feynman was a student of Wheeler's, and Wheeler's, it was at Princeton. He suggested that you should look at the polarization of these photons, and these two individuals carried out an experiment in 1949 and showed exactly what we said, that if one's horizontally polarized and the other's vertically polarized, and then you get them to flip, one of them to flip, the other one will flip immediately. So this led people to looking at this and trying to figure out the mathematical definition of this. It can be paraphrased as saying that the maximal knowledge about the whole of the system does not imply the maximal knowledge about the individual parts of the system. So the example I gave you was the system had zero spin. But if there's two particles and one's spinning clockwise and one's counterclockwise, the net spin is zero. But if one of them flips, the other one will flip immediately, and the net spin will be zero. So just knowing about how the whole system behaves doesn't give you really any knowledge about the individual particles that are in this.
Except that you can say if one is doing one thing, the other must be doing the other thing.
Mhm.
Well, that's something.
Yeah, but it doesn't say which is doing which.
Okay. But if you just know what one is doing, then you know what
Right.
the other one is doing.
Right, but as soon as you know what one is doing, you violated, all you know is that the total spin is zero.
Okay.
So this is basically what goes on with entanglement here. And Einstein got a lot of people interested in this in 1935 when he wrote some paper. Einstein, Podolsky, and Rosen, EPR, are the initials, and in the paper, Einstein called this action a spooky interaction because it happened instantaneously over any distance whatsoever, and nobody'd seen anything like that before in physics, so that made it spooky. So one way that this gets resolved is you say, well, quantum theory that we know today is simply incomplete. And if we knew something else, there's probably other things going on that we're not smart enough to include it in our theory. And so they're called hidden variables. They're things that we could actually measure somehow, but so far we haven't figured out how to do it. So the state of these particles, when you measure it, contains some of these hidden variables. And these things determine right from the moment of separation what the outcome is going to be. Now, what Ron Cowan saw was that each of these particles is coated with these blocks of information that are constantly scanning their surroundings. So when they detect the change, say, for example, another particle flips its spin, then that gets noted by the particle that's doing the scanning. And the rule apparently is that particle will then flip. If one flips, the other one flips. And I have no idea why that's the rule. It just is the rule. It's the way things work. It's like Newton was asked, what's going on with gravity? He says, I don't know how gravity works. All I know is if I have these equations, I can tell you, what happens, but I have no idea what causes it. Okay. So with that as a prologue, now we're going to go into a different piece of quantum mechanics called the many worlds interpretation of quantum mechanics. So there was, again, the same guy, John Wheeler, and he had a graduate student, Hugh Everett, and he asked Hugh Everett to take a look at trying to do a better job in quantum mechanics. Now, typically, what goes on there is you're focusing on one thing, like hydrogen atom with one electron. And instead, he decided to focus on collections of these things, arbitrarily many atoms, fill in the blank. And what he came up with was he said, well, the way that the world works is that there are these transitions, say an electron flips in spin, or an electron moves from one energy level around the nucleus of an atom to a different energy level, and it emits, the energy change results in a photon being emitted. So if that's what's going on, and that happens all the time, you know, with atoms and everything that's making up the universe, then every time that there's any transition whatsoever, you end up with a different timeline. So if one of the atoms in your body simply has becomes agitated and puts out some heat, and that's enough to make an electron change energy levels, then all of a sudden your body splits into two bodies, one on one timeline and one on the other. And so that's what this picture is. It's showing a movie, the timeline, but then it splits. So what Everett did was he said, well, this happens continually. So there's timelines upon timelines, and there's uncountably gazillions of these timelines. For example, in your body, you have 50 trillion cells on average, and each of those cells has on the order of, you know, probably 1 million atoms. And so if you look at 50 trillion times times 1 million, you end up with that many possible atoms, and that's just in your body. And each of these things keeps changing state. Whenever that happens, your body goes off onto a different timeline. You have multiple bodies, multiple yous out there. And so this is interesting because it says, therefore, that everything happens, everything. But instead, with everything happening, you still have to interpret what in the world the answer is here, okay? So when he went through this, I actually read his doctoral dissertation because I was curious about this. In the 1970s, someone else named Bryce DeWitt popularized these ideas, and he's the one who called it the many worlds interpretation of quantum mechanics. So you can write down the equations for quantum mechanics, and in these equations, you have world upon world upon world there, or as I would put it, timeline upon timeline upon timeline. And that's what's going on. Now, what in the world could you do with this? What's going on? So the reason that he did this was something that Ron observed. When you do this double slit experiment, where you send an electron through a slit, and you get on the other side of the slit, if you put a screen there, you get a line of electrons. And then if you put in two slits that are close to one another and shoot the electrons at it, then you get a wave pattern, a wave interference pattern on the other side of the screen. So instead of getting two lines showing electrons went through this one, electrons, all of a sudden it turns into a wave function. So it went from a particle to a wave. And the reason why this is disturbing is, how in the world is it possible? Is it a particle or is it a wave? What's going on here? And the thing that Ron observed was there was the scanning taking place, and as soon as the electron detected that there were two slits there, it became a wave immediately. Or if there was one slit, it was stayed as a particle. That was what happened. But instead, what the physicist said was, oh, this wave function for the electron allows it to be doing anything you could imagine. But as soon as we measure it, so now the observer comes into this. As soon as we look at the electron and we measure it, then we immediately change everything, because now the system has changed. It's not simply the electron going through these slits, it's the electron going through the slits and an observer. And so the observer causes the state of the electron to change, to collapse from all these possibilities into either it's a wave or it's a particle, one or the other. Now, what Ron did was, by looking at the scanning of the information that coats the electron's doing this all by itself. And this is the way the universe works, is it's just naturally doing the scanning, and it will pick the path that's appropriate for these rules. I have no idea why the electron decides to be a particle or wave, but that's what it does. Those are the rules. So the idea here is what he did here by keeping this theory together, he preserved all of the existing quantum mechanics, but he said there's one gigantic wave function that describes the entire universe, and it's got billions and trillions and trillions and billions of possible states to it, or if you will, timelines, and that's what's going on, and they're all there at once, and so you're living in many different timelines, and that's how everything works. Now, the thing that we saw in doing this is each of these worlds is real, but there's only one world that we're in, and so which world is that? And a lot of people argued about this, including Wheeler and many other people. And this one guy, Everett himself argued it was the only completely coherent approach to explain the contents of quantum mechanics and the appearance of the world, the world consists of these many, many timelines. That's the way it goes. And Deutsch, who was another great physicist, said that this isn't an interpretation. To call this an interpretation is like talking about dinosaurs as an interpretation of the fossil record. You know, the dinosaurs really existed. What are you talking about? So to summarize, what Everett said was, rather than relying on external observation, one could model an object and its observers in a purely physical system within a mathematical framework, which is called quantum mechanics. And this discarded this ad hoc description that the physicists had adopted. Hold on a second. Yeah, Al, we're just in the middle of class. Is it anything quick?
Just checking in with you guys. Everything come up.
Okay, we'll get back to you. So where we ran into this before, one of the problems with this work was that Everett went ahead and finished his doctoral dissertation on it, and it was completely ignored. Everyone said, this is like the dumbest thing I've ever seen. Why am I going to even give it the time of day? And then Everett went to some conferences and gave talks on this, and people attacked him vocally. So,
Well, I think when you can explain that, you'll have something interesting to say.
so what he decided to do was drop out of physics. He said, this isn't any fun. I quit. He went into the Pentagon, and that's where he spent his career. Never did any more work on this.
Which is a shame, I mean.
Yeah. This is just the description of this cat vial, box of the poison vial, and so forth, just to show how this fits into this thing. In other words, in what he had, both the world where the cat is dead and the vials have been opened is one timeline, and a totally separate timeline. So the cat is alive and the poison hasn't gotten out, and they're both there, which, you know. But people said, well, then, you know, what have we done? We've covered everything. There's nothing left to you haven't left anything out. What could you predict out of this? And
Well,
having said that, this is still around, and many physicists believe that this is the correct description of quantum mechanics, that there's some huge wave function that describes the entire universe, And we're constantly splitting into these different timelines. They're philosophically, many of them love it. That's after, 50 years of popularizing this thing. But there's a lot of other physicists that say, what can I do now that I couldn't do before? So, in many ways, this is a deterministic theory because every change you can imagine happens. So if that's the case and you didn't leave anything out, then everything is completely determined. You have all these different timelines and so what? That's what you're saying. But what happened here was there was a lot of discussion after this, and what happened in him doing this was this led to people thinking about what we've touched on, where we had Nostradamus, and Nostradamus had his quatrains. And Nostradamus said clearly in the quatrains that I see this as a possible future. This is not the only future. This is a possible future. And in this future, he saw Napoleon, Hitler, and then this third person, which he called the Antichrist, who was born in the Middle East in the 1950s, 1960s, and his parents were killed by terrorists, and he was raised by an imam who was rabidly against anything Western, and he became the Antichrist. He started off and was very successful in getting people to pay attention to him, and then he turned onto it and tried to become the dictator of the world, which led to this huge world war that Nostradamus described. So that is one of the worlds that's out there, but something changed. In the world that we're in, there was no, if there is an Antichrist, he probably was born, but he was never successful at creating this dictatorship or trying to create it and creating this world war that Nostradamus saw, that somehow we've been able to reach in and influence the choice of these different timelines. And in fact, that's what Nostradamus said. He said, I see these many, many timelines. And so Nostradamus was saying, I see these many worlds that you're talking about there. But some of them seem to congeal, seem to be the natural path. And one can argue that that was due to all of the consciousness that we have, all of the different archetypes that create consciousness leads to following one particular path. But really, the many paths that we're talking about here give you free will.
Right.
You can go into any world you want to. Okay, but at the end of the day, one of those timelines is your timeline. That is what you live in, and that becomes the timeline with enough people agreeing on it that they end up following that timeline. So that becomes the history of the world or of the universe. A different example that came up we talked about was that the CIA in the 60s and 70s decided to hypnotize a lot of people and then regress them, ask them to go back to past lives. And when they did this, they discovered that there were a number of people that saw that the South had won the US Civil War, whereas in the world that we're in, the North had won the US Civil War. So something happened somewhere. There were enough people on this other timeline that they saw this happening, but they were able to leave that timeline and come to this timeline where the North won. So one interpretation of this is these timelines could be thought of as like many rivers, many things flowing out into the future and constantly branching, as you can see here. But what might be happening is that our consciousness is in fact influencing these things. So for example, with Nostradamus, there were enough people there that were horrified at having a antichrist become the dictator of the world. And they drove our timeline away from that, so that we didn't undergo the trauma of a gigantic world war and everything that happens with it. The Antichrist could still be alive, but he definitely doesn't have a gigantic army, and he isn't carrying out all kinds of terrible things. So consciousness could very well influence which of these timelines, which of these worlds do you end up going on. And it gets into other things beyond this. I'm just looking here to see. That's what I. Oh yeah, the other thing that happens is apparently, you know, these timelines cluster together, so you can have, you know, little variations from timeline to timeline, but by and large, the history is the same for everybody. So that takes us off into complexity. One of the things that happened in the 19th century was Charles Darwin developed a theory of biological evolution. And what he said was, all of the species arise and develop through a natural selection of small inherited variations or mutations. In other words, these are little branches in the timelines. And this increases that individual's ability to compete and survive and reproduce. And so if you have a small edge, and this increases from generation to generation, then you can end up carrying the day. So this was revolutionary and so forth, but Darwin was probably onto something, but it was probably deeper than what he had. In fact, the current thinking is that it isn't simply biological evolution that gives rise to this distinct set of rules of living organisms, okay? Instead, when you have complexity, the greater the complexity, in other words, the more mutations, the more timelines you have, the more likely it is that one of these will be better than all the rest, whatever it is. You've got enough choices there to sort out, and one of these will get picked. And so the timeline that we're on apparently is the one that we have selected that is the most resonant with our consciousness here. And this is based on gathering, they simply call it information. Whatever the information is going to contain the seeds of some attribute that will allow you to become better, whatever better means. So what happens here is that the basic laws of physics are really not complete, because they're going to evolve. With all of this complexity, or if you will, evolution, this will introduce changes in the functions into the space and time and everything that we see around us. And this will lead to new laws of physics that will just naturally arise out of this. That'll be, and they'll change as we go through this. And it could very well be that our consciousness, which is again a type of an energy, that this is being shaped as well. And there's matter and there's energy. They're just mirror images of one another. So the consciousness, or your soul, whatever you want to call it, ends up shaping what is picked out. What's the most favorable complex path that's picked out here to go through these things, and that is starting to become apparent to more and more people. Now, what Ron did here, we go back to our picture here, we had this universe of 26 dimensions. There's 2 time dimensions, and 24 space dimensions. Now, with this many worlds interpretation that we just talked about, one time dimension, which is here for us, involves free will. So the many worlds that we're talking about are going to be here with the free will shaping, giving us the chance to shape how time will evolve, which timeline will follow here. The one over here, the time dimension here, this is for dark matter. This is for the so-called Akashic record. This is tracking the actual timeline of the true universe. So even though we have all these possibilities over here in this space, over here, there's one of them that's been picked out that is the most preferred by all of the different rules that we have, and that's what gets stored here. And way up here at the top, where we have just nothing but energy, entities, the same thing is true. These souls or spirits will evolve over time into higher and higher entities, whatever that means. We have no idea. And so there is a coherent picture here of what Ron was talking about and this many worlds and interpretation of quantum mechanics. What Ron highlighted was this information, that the information is everywhere. It coats the walls of the space compartments, and it controls our physics, our chemistry, our biology, and our souls that are over here, the matter side, the dark matter side, and then the etheric spirits that are here as well, all get controlled by this information, which is running on many different timelines, and it controls everything. And this is the mechanism that you end up picking out with the information, which is the best path that you're going to choose. So what Ron did was a huge achievement to come up with this stuff. So now we're going to go off to consciousness, as if we aren't confused enough. So consciousness is the awareness of a state or an object, either internal to oneself or to one's external environment. However, the nature of consciousness had led to, over the millennia, many analyses, explanations, and debates among philosophers, scientists, and theologians. Everybody agrees that you seem to look out your eyes, and so maybe there's a little person behind your eyes that's looking out through your eyes and sees this stuff around you. Maybe that's what's going on, but that doesn't seem to be too useful. It doesn't really get to the crux of what consciousness really is. And so there's been many people that have studied these things. And I just picked Webster's third dictionary, 1966, no less: awareness or perception of an inward psychological or spiritual fact. Intuitively perceived knowledge of something in one's inner self. An inward awareness of an external object, state, or fact. Interest or concern with an attribute or some sort of noun. The state or activity that's characterized by sensation, emotion, volition, or thought. So you see, there's all these different definitions here, and they're walking around what is conscious. I don't think any of them do the job of explaining what is consciousness. Here's a guy named Sam Harris who has a internet podcast. He's a philosopher, and he says, at your level of experience, you're not a body of cells and atoms, you're a consciousness, and it's ever-changing contents. So the way that he sees it is consciousness is evolving, it's subjectively experienced, it's always present, and it could very well be in inanimate objects as well as animate objects, things like stones, because of the nature of the complexity that are there. Stones, for example, go to certain types of stones. Well, that means they didn't go to other types of stones. They ended up in a particular type of stones that people have seen. That's the preferred direction. That's the preferred timeline for the stone, for the inanimate object. other people argue that the consciousness is symbolized by the mythical bird that is found at the start of the Zhuangzi, which is the way, the Tao. And this bird's name is of a flock, Peng, it's of a flock. Yet its back is countless, thousands and thousands of miles across, and its wings are like clouds arcing across the heavens. So like of a flock whose wings arc across the heavens, the wings of your consciousness span to the horizon. At the same time, the wings of every other being's consciousness do the same thing. So you're all of one flock, one bird among all these other birds. So that's a metaphor for what consciousness might be, but what the mental processes are for consciousness, and then the physical processes, for example, in our brain, appear to be correlated, okay? But we still don't really know the nature of this correlation. We saw, for example, in music, that music activated a particular part of the brain, which was the same area of the brain that was activated with sexual ecstasy and with taking drugs like LSD and other drugs like this. So it was a pleasure center. But so what? what good does that do? Descartes was the first one to deal with this, and he called it the mind-body problem. He said that consciousness resides within an immaterial domain, the realm of thought, and in the realm of material things. He suggested that the interaction between these two domains, the mind and the body, occurs inside the brain. And he knew something about the brain, so he said maybe the pineal gland is where all these things interact, but he didn't know. There's modern work on this, so I picked out this Anaka Harris. The better metaphor for consciousness might have been sitting on the other side of the living room in my mother's piano. That is, the piano was arranged in a configuration of matter, and this complexity that became the piano allowed humankind to send Bach out as play the music of Bach, and this has gone off out into space with space satellites and space probes. So music might be what it's all about. This is just an example of what consciousness might be. Consciousness might be vibrations, might simply be the resonances that occur that lead to this higher order thing that we call consciousness. The other thing is that it's not the instrument that does this, but it's the music itself that could be the consciousness. And this is just an idea. Maybe it's true, maybe it isn't. It's tough to test these things, but she's a very entertaining reader, and that's why I cited what she was doing in here. She's in this book, she surveyed 2 decades of work with neuroscientists and had 30 hours of interviews with physicists, and so it goes. And she wrote an earlier book in 2021. This is her latest here, that dealt with the notion of consciousness, and she's still not exhausted it. So defining consciousness as just the pure fact of felt experience, again, we're following one particular timeline, the timeline that appears to be the preferred timeline of our life, of our world. And the question is, why is this? What in the world would make this be the way the world behaves out of all the ways that the world behaves? So she looks at some systems that have all kinds of internal processing and deals with trying to sort these things out. It's interesting that people now are arguing that birds of all sorts, crows, parrots, cockatiels, macaws, have developed consciousness on their own, that they're very, very smart, and they've developed it in a totally different manner than mammals have, or than reptiles have. And then what goes with this is you have octopus, and the octopus, you know, being in the ocean and having a totally different environment, it's developed consciousness in its own way, which is totally different from the way mammals and the way birds have it. And so there isn't any one definition of consciousness. You have to look at all these different things here. And we picked out Emily Dickinson here, who marveled at how an atom fell, and yet the heavens held, blue and solid. How have I peace except by subjugating consciousness? And science were mutual monarch. How can this be? So that's Emily Dickinson. So the hardest concession here is that we have to abdicate that there's a self. Is there really a self there after all? Or is it simply something that we think is there, and it's resonating because we have a soul, and the soul is the thing that's activating, that's creating this consciousness. You want to keep an open mind here, because so many of these things are so hard to sort out. You have to challenge a lot of innate intuitions about experience and what is called reality. And as we've been arguing here, that what we see through our eyes is not the true reality. There's a lot more to it than that. And so here in this book, which I encourage you to take a look at, just the simple and profound acknowledgement that everyone around me is having a full, rich, deep, conscious experience that's unique to that person. It's private, but it's all-encompassing for each of these minds that is out there. So with every passing person, there exists an inner world as undeniable, as textured and layered as I know mine to be. And it's strange that people ignore this, that there's all these people walking around that are conscious. And so the collective consciousness is all of these things put together, which might be greater than just what she's talking about. She looked at all kinds of things like dogs. There were fireflies here. There were all kinds of different experiences that she came across, all of which suggested that maybe we're just a controlled hallucination, and that even what we think of as space isn't really fundamental. That it arises out of some need of consciousness to create what we call space around us. That gives you some idea of how little is known here. And then the final thing is that we're not simply embedded in nature, we are nature. That is, we're participating in this, we're on this particular timeline, and we reflect on this through consciousness, through what we experience, which is unique to each of us. A century ago, Virginia Woolf arrived at the same elemental truth, but a different route. The garden path along which she reckoned with the meaning of life, parting the cotton wool of daily life to conclude, behind the cotton wool is hidden a pattern. We, I mean all human beings, are connected with this. The whole world is a work of art. We're parts of the work of art. Hamlet or Beethoven quartet is the truth about this vast mass that we call the world, but there is no Shakespeare, there is no Beethoven, and certainly and emphatically there is no God. We are the words, we are the music, we are the thing itself. So there you go. I deliberately went off to people like this because the dictionary meanings or the physics just don't hack it. And I think these people have a very fresh view of what's going on. I'm just going to close with this little discussion on free will. In free will, there's no pure perception of a flower, of a mountain, of a person. Everything we look at, we partly see a reflection of ourselves, or what we think we ought to see is a different way to say it. We have an internal model that we're projecting outside us. And if we're conscious enough and unafraid enough of being surprised, we'll keep testing the model against reality and incrementally seeding that which we imagine to what we believe is actual. Now, that's the question is, how do you know what's actual? One measure of love, perhaps the deepest measure, is the willingness to remove the projection in order to perceive what is truly there. So you have to go bare naked, remove everything. So there's both sorrow and consolation, and knowing that although we can ever glimpse parts of the totality beyond us, we can keep trying to see more clearly in order to love more deeply. In the Scottish Highlands, she discovered how illusions of perceptions depend upon one's position, physical as much as psychic. There was a scatter of white flowers and grass. Looked at through half-closed eyes, they blaze out with a sharp clarity as though they had actually risen up out of the background. Such illusions, depending upon how the eye is placed and used, drive home the truth that our habitual vision of things is not necessarily right. It's only one of an infinite number, and to glimpse an unfamiliar one, even for a moment, unmakes us but steadies us again. So this overwhelming infinity of possible perceptions is what attention evolved to protect us from. That intentional, unapologetic discriminator selected a handful of parts out of the totality in order to construct this projected image. And she goes through, again, the myriad tessellated realities. So she's touching on this many worlds idea, this many timelines idea, many different realities that are there. And how can I number the worlds to which the eyes give me entry, and so forth. It's very, very beautiful text here. Truth is so great that I wouldn't like to speak or sleep or listen or love, to feel myself trapped with no fear of blood outside time and magic, within your own fear and your great anguish, and within the very beating of your heart. All this madness, if I asked it of you, I know in your silence there would be only confusion. I ask you for violence in the nonsense, and you give me grace, but your light and your warmth. I'd like to paint you, but there are no colors because there are so many. And in my confusion, the tangible form of my great love. So this is taken from the diary of this Frida Kahlo, who is
Hello.
Kahlo. Nothing compares to your hands, nothing like the green gold of your eyes. My body's filled with you for days and days. You're the mirror of the night, the violent flash of lightning, the dampness of the earth, the hollow of your armpits is my shelter. My fingers touch your blood. All my joy is to feel life spring from your flower fountain that mine keeps to fill all the paths of my nerves, which are yours. So here you go. Very different view of these things. Here, they're chained words which we could not say except on the lips of dreams, and everything was surrounded by the green miracle of the landscape of your body. Upon your form, the lashes of flowers responded to my touch, the murmur of streams, or all manners of fruits in the juice of your lips, the blood of the pomegranate, the horizon of the mami, and the purified pineapple. I pressed you against my breast, and the prodigy of your form penetrated all my blood through the tips of my fingers. Smell of oak essence, memories of walnut, green breath of ash tree, horizon and landscapes. I traced them with a kiss, oblivion of words will form the exact language for understanding the glances of our closed eyes. You are here, intangible. You are all the universe which I shape into the space of my room. Your absence springs, trembling in the ticking of the clock and the pulse of light. You breathe through the mirror. From you to my hands, I caress your entire body. And I'm with you for a minute. I'm with myself for a moment. And my blood is the miracle which runs in the vessels of the air from my heart to yours. So there you have it.
Well, in Buddhism, there is pure perception. I mean, you have to meditate a long time to get there, but it's still there.
Yeah, these people never went into deep meditation, but they're trying to describe.
Yeah, I know. Anyway, I just thought I'd mention it.
Yeah. Any comments?
Wow.
Comment?
It's still percolating.
I think we're evolving toward,
It evoked a lot from me, but I'm not
well,
ready to articulate it.
yeah, we're walking around. I think there's something here, but I don't know what it is.
Right. Well, you haven't meditated enough, that's why.
Huh.
Thinking of, and I guess the Tao that cannot be told.
Right.
Somehow,
When you say the way or the Tao,
right,
that you can't tell it.
the Tao that can be told isn't really the Tao.
Well, you can, if the person can hear it. I mean, the thing is about the way or the deeper understanding of the universe that comes from deeper awareness is reliable, but you have to be able to be there to see it. Like when you have when you're being telepathic, like if you can talk to somebody like the Dalai Lama, his mind is a very vast reality of unfoldment that's boggles the mind and has dimensions to it that are just unimaginable. But if you have somebody who has that kind of awareness, well, it's just taken for granted.
Right.
So it's kind of like a different understanding of the mind.
Yeah, I should have gone to Dalai Lama and tried to look for some quotes there.
Yeah. Next time.
Violence?
It feels the closest, I guess, to what. I don't know, I remember thinking about this kind of thing a lot when I was a very young child. I don't know if all children do, but just so much of that. Well, if I'm wondering if something is happening or not, and I open the door and I look and I see what's happening, does that mean the other thing can't possibly happen because I've blocked it by seeing that thing happen? And I just always thought that way. I don't know if that is a natural way of thinking. But so then, to encounter this in the thoughts of other people who have pondered these things so deeply for many years, it's kind of reassuring.
Right. Now, I think it's interesting that so many of these physicists say, yeah, I really think that this many worlds interpretation is the right framework, but they just leave it at that point. They never really pursue, what can I do now that I couldn't do before? It's the interpretation of all of this stuff. It could very well be correct, because if your theory is that it encompasses everything, that everything that you could possibly imagine happened on one of these timelines, well, then you didn't miss anything. So now what do I do?
Yeah.
That's why I got attacked. He said, you know, you're not stating anything useful. But I think he was. It was just that he was, you know, he was too early.
Well, there's many levels of awareness, and people are born with different talents.
Right.
And
And you could see that the levels of awareness could evolve. You could go to higher levels than what you have now,
oh, absolutely.
and beyond those, the even higher ones.
Yeah. But when you get to the higher levels of
The
awareness,
problem is that the words don't convey anything. It just says you're at a higher level. So what?
that's right. But it's still understood. Can't
So,
be necessarily communicated.
right.
Well, I think it might change where you're coming from and how you relate to
Yeah.
situations and people and your relationships with situations and people and things and ideas. So on the one hand, there may not be a dramatic change on the outside, but it may change, excuse me, everything that happens.
Yeah, I always argue that when you go through any of this stuff in science, you have a phase where you gather data or information, and then you go through and model it, so there's some perception that you can place your observations into some set of buckets or categories or whatever it is. But then the third phase is the one that people miss, and it's the interpretation. Now that you've done that, how do you interpret what you see? And I've seen people go through the first two steps and interpret totally 180%, 80 degrees wrong what's going to happen. And I'm dumbfounded. And so there's this interpretation side of things, especially for this many worlds where everything is included. And yet we sense from Nostradamus that there's groupings of timelines, and where somewhere in what these many worlds, there's apparently some grouping, something is shaping certain paths over other paths, and that, you know, that's the secret sauce that we don't really understand.
Right.
Enough?
I think one thing is that you start to look at things like a concept like cause and effect. Really different
Yeah, you do.
of what's a cause and what's an effect. And the things you do therefore are affected by that.
Right.
And I always say, I think we have, in a way, more free will than we may wish we did, and less at the same time. But I think it's in different places than we may like to think. And That sometimes it's more than we realize, and sometimes it's a lot less than we fantasize. And there's still all kinds of antecedent causes and and then, ripples that we don't necessarily ever connect those dots. And a lot may be predetermined. And that may go back several levels that, we don't acknowledge or understand.
Yeah, or you have someone like Nikola Tesla. What did he think of reality? Who knows? Probably,
I think it's probably a lot more fluid than we like to pretend,
yeah,
but I think it makes a difference how we relate, how we love, how we understand. Are we capable of just leaving space for certain things?
mhm,
To me, that's a huge kind of almost an unconscious decision. I don't know.
yeah.
Um,
I mean, I think it's interesting that the French in their school system, if you take the college track, the last year that you're in what would be gymnasium, they actually have a philosophy class. The French believe it's so important that you should be educated in philosophy. Exactly, these sorts of concepts. And they think you should spend a year on it, out of all the things you could do in that final year of gymnasium before you go to college. Whereas in the US, forget it. So,
well, I think this was very thought-provoking and
yeah. But let's see where it goes. We will see you next week, Bruce.
All right,
We'll see what we come up with. Have a good.
okay. Yeah, I hope it's not going to be snowing.
that
I know.
All
Okay, bye-bye.
right, bye.